Greetings and welcome to the final video on the topic of equations and inequalities, which is in chapter 3 of the algebra book for the year 12 AS course. So in this lesson we're going to be looking at, in particular, how we graph inequalities and identify graphical regions. But before we start that proper, we do have 4 warm-up questions almost as ever to try, so here they are. So what I'm going to ask you to do now is to try these questions first before playing the solutions, and then only after you've tried every single one of these questions, play the video and double check if you've got them correct. If not, use a video to help to see where you've gone wrong. So let's have a look at question 1. So for question 1, it tells us, for question 1 and question 2 in fact, to sketch the curve and show the coordinates where the intersection with the axes occur. So for question 1 we have y equals x squared minus 9. We should know that this is difference of 2 squares. So we can say this is x plus 3, x minus 3. Okay, so based on that, we can see that the intersection with the x-axis is going to be at minus 3 and plus 3. And that the y-intercept is going to be down at minus 9, because when x is 0, y is going to be 0 minus 9, which is obviously just minus 9. So I'm going to try my best to get this nice and symmetrical looking. I'm not a very good graph sketch on these devices, but that'll have to do, I'm afraid. Far from perfect. And this point down here is minus 9. And so that's question 1 done. Question 2, same idea, just different equation of the curve. What we should notice here is we can factorise out a 2 from all of this. So we get 2 lots of x squared minus 7x plus 10. Now this will factorise quite nicely. So this becomes, if you think of 2 numbers that multiply together to give us 10, yet when we add them give us minus 7, those 2 numbers we should realise are minus 2 and minus 5. And so this becomes 2 lots of x minus 2, brackets x minus 5. So this expression will be equal to 0 when x is either 2 or 5. And so this quadratic has an x-axis intercept at 2 and 5, and it will intercept the y-axis at 20, because if we sub in where x is 0, we get y equals 0 minus 0 plus 20, which is obviously just 20. So this one is going to look something like this. So that's going to be 20 here. That's going to be 2. And over here, that's going to be 5. Question 3, we're asked to solve this equation, which seems quite awkward, and in fact could be quite intimidating. How on earth do we solve this? The key concept here, the key insight you need to make, is to realise that 16 and 8 are both powers of 2. And so we can rewrite 16 as 2 to the power 4. All of that to the power x plus 1. And 8 we rewrite as 2 cubed. And all of that to the power 2x plus 1. So all we've done here is we've just rewrote what 16 is. We've rewrote it as a power of 2, and the same deal with 8. We've rewrote that as a power of 2 as well. Now for each base we can use a power rule and multiply the 4 by the x plus 1. So for the power of 2 we get this the same as 2 to the power of 4x plus 4. And using the same logic for this one over here, if we multiply 2x plus 1 by this power 3, we get that the new power of 2 is equivalent to 6x plus 3. So now we have 2 expressions set equal to each other. The bases are equal, and if they're both equal and the bases are equal, it stands to reason that the powers also must be equal. And so the bases are equal, Therefore, this 4x plus 4 must be equal to 6x plus 3. And so what we've teased out of this awkward-looking initial equation is actually a very simple linear equation. So we can say that 4x plus 4 must equal 6x plus 3. Now this is actually fairly straightforward to solve. So if we subtract 4x on both sides, we get 4 equals 2x plus 3. Subtract 3 from both sides gives us that 1 is equal to 2x. Then half both sides, we see quite clearly that x would have to be a half. And we can verify that result using a calculator to double check the answer's correct, which I'll hope you see it actually is. Question 4 again is using revision of indices and surds and powers. So here we've got this weird looking equation where a quarter all to the power t minus 3 equals 8. Again, the key insight here is that 4 is a power of 2 and 1 over 4 is a reciprocal power of 2. Okay, so it might just be worth making a note to the side. So a quarter is the same as 1 over 2 squared. So it's a reciprocal of 2 squared, but what we need to remember from the laws of indices from the previous chapter was that 1 over a power is the same as that power minus. Okay, so 1 over 2 squared is the same as 2 to the power minus 2. And so what we've done here is we've just changed this a quarter using powers and the laws of indices and rewrote it in this form. And if you want to double check on a calculator, 2 to the power minus 2 is indeed a quarter. So we just rewrite a quarter in this form. So then we get that 2 to the power minus 2 all to the power of t minus 3 must equal 8. So using the power of the power rule, we can multiply this minus 2 by the whole of t minus 3. What we get when we do that is 2 to the power of minus 2t, and minus 2 multiplied by minus 3 is plus 6. Remember, minus multiplied by minus gives us a positive. And then 8, we can actually rewrite 8 as a power of 2 as well. 8 is the same as 2 cubed. Okay, so all we've done here is rewrote 8 as a power of 2. Now at this stage it becomes pretty much exactly the same as what we had in question 3. We have two expressions which are equal to each other. The bases are equal, therefore the powers of these bases must be equal too, because otherwise one wouldn't be equal to the other. In other words, minus 2 plus 6 must equal 3. So again, we're taking something awkward and boiling it down to something which is actually much more simple using our prior knowledge and algebra skills. So what I'm going to suggest we do is we add 2t to both sides to obtain 6 equals 3 plus 2t. Now subtract 3 from both sides, gives us that 3 equals 2t. Finally, when we divide through by 2 on both sides, we see that t is equal to 3 over 2, which you can rewrite as 1.5 if you so wish. And that's the warm-up questions completed, so we can move on to the main course of the lesson. Now what we need to talk about and mention is the idea of putting inequalities on graphs. So the first thing to mention is that just as we can interpret the solutions of equations graphically, we can do the same for the solutions of inequalities by interpreting these graphically also. When solving equations graphically, we're interested only in the precise points where the lines or curves representing the different equations intersect. These intersections represent the exact values of the variables where one equation is equal to the other. In other words, the intersections relate to the solutions of solving the equations. However, the difference with inequalities is where you have less than or greater than rather than equal to. We're not interested in the intersections of the lines and curves only, but actually we're also interested in where one equation is less than or greater than the other. So graphically, in plain English, less than, where one equation is less than the other, corresponds to below the other equation. And where one equation is more than the other, that corresponds to that equation being above the other line or the other curve. To summarise it, if you've got two equations, let's just call them f of x and g of x, then the values of x for which y equals f of x is below g of x satisfy the inequality f of x is less than g of x. To flip that the other way around, the values of x for which the curve f of x is above g of x satisfies the inequality where f of x is greater than g of x. And the easiest way to see this is just by visualizing it as such. So here, the blue curve is f of x, and the black line is g of x. And so if we have a look at this right-hand section of the blue curve, we can see here that f of x is above g of x. The blue line is above the black line. And we can see that that's the case when x is greater than 5, in other words, over here, and also f of x is greater than g of x, the blue is above the black, where x is 2 or less. And so, like we mentioned earlier, these satisfy the inequality where f of x is greater than g of x. F of x is below g of x between 2 and 5. So between 2 and 5, here, that's where the blue line, the blue curve f of x, is below g of x for when x is between 2 and 5. And that's satisfying the inequality f of x less than g of x. So just to recap, f of x greater than g of x is where f of x is above the line. That's where f of x, the blue line, is above the black line. This one here, where f of x is less than g of x, that means where f of x is below the black line. The actual solutions, if it were an equation, equal to are the critical points x equals 2 and x equals 5. So all we need to do when we're talking about inequalities is we find the solutions if it were an equation, and we treat these as the critical points. Then, to make that into an inequality, we consider either side of these critical points and also between, depending on the inequality we wish to solve. So let's have a look now at a couple of examples. So example 1. Let's picture a straight line, let's call it L subscript 1, with equation y equals 12 plus 4x. The other one, L subscript 2, has equation y equals x squared. So question A, on the same set of coordinate axes, let's sketch L1 and L2, labelling all intersections of axes and all coordinates of intersection of the graphs. So let's see if we can set out doing that now. So y equals 12 plus 4x and y equals x squared. So what I'm going to consider first of all is the points of intersection. We can sketch these easily enough. That's going to have a gradient of 4, y-intercept of 12, and that's a standard parabola, so sketching is not going to be a problem. What is going to be a problem is considering where these two equations meet. They're going to meet where one is equal to the other. In other words, where this one here, where x squared happens to be equal to 12 plus 4x. Well, we can rearrange this into the standard quadratic form by getting this as a quadratic equal to 0. And so if we subtract 4x on both sides, this becomes x squared minus 4x. Then subtract 12 from both sides, it leaves us with 0 on the right-hand side. Okay. What we can now do is factorise this expression on the left by thinking of two numbers which multiply to give us minus 12, yet when we add them together give us -4. And those two numbers are going to be +2 and -6. And so x plus 2, x minus 6 is equal to 0. Therefore, one equation is equal to the other. The solution of this is when either this bracket's equal to 0, when x is -2, or when this bracket's equal to 0, and that's going to happen when x is equal to 6. So we've got solutions either side of the y-axis. So first of all, let's sketch y equals x squared. Again, apologies in advance for my terrible sketching of curves, but here goes nothing. Touches there, and back up again. That'll do. I know it's terrible, but please forgive me. And this one, y equals 12 plus 4x. Luckily I can cheat here and just use a straight line for this one. So this one's going to be something looking a bit like this. Okay, it does say sketch, and so I can get away with this not being to scale. Let's just label what we know. So this would intersect the y-axis at 12. Not that we are asked to do this, but it doesn't hurt. And this is going to intercept the x-axis when this is equal to 0. And that will happen when x is -3. Now, this intersects with the blue one where x is -2. So we can add this in here. So that point is -2. And likewise, the other coordinate of intersection is over here, and that's going to be where x is equal to 6. Now it does say the coordinates of intersection of the graphs. I'll give you a bonus mark if you can spot the little spelling mistake here. Okay, the spelling mistake is unneeded E where it says intersection. So I'm going to just almost pretend that didn't happen, but there we go. Whoops, making a pig's ear of this. What'll bug me now is if I should have mentioned this at all. Maybe you would have never noticed had I not fessed up. I made an issue over what should have been nothing. Anyway, intersection. So anyway, we need the coordinates. And so when x is -2, what would y be? So let's just consider that now. When x is -2, y is going to be 12 plus 4 times -2, which is going to be 12 minus 8, which is going to be 4. And so this coordinate here is -2, 4. And this coordinate here, where x is 6, we can substitute x equals 6 into either one of these equations. I'm going to go for the quadratic. When x is 6, y, which is x squared, is going to be 6 squared, which is 36. And so this coordinate is 6 and 36. For part B, it says write down the solution to this inequality where 12 plus 4x is greater than x squared. Okay, so what we're going to do here is just think about 12 plus 4x. Well, 12 plus 4x is this straight line here, which is L1. X squared is obviously this blue parabola, so I'm going to label this L2. I'm now going to consider where this here is greater than x squared. And if you recall what we mentioned in the previous few moments, where one is greater than the other corresponds to where one equation, which has been graphed, is above the other. So whereabouts is this line, L1, which is 12 plus 4x, whereabouts is this yellow one above x squared, this blue parabola? Well, obviously you can see it's above, in between these points of intersection. So we're looking in this region here. Over here, it goes below the parabola, and down here, below -2. Again, it ends up being below this blue parabola. But in between -2 and 6, that's where we're interested in. And so for part B, we're wanting for x to be in between -2 and 6. And just as an opportunity to remind ourselves of how set notation works, we write this as x such that x is in between -2 and 6. Let's have a look now at a second worked example. So question 2. Same setup as question 1 really, but only now we've got a parabola which is slightly more complex. So this parabola for L2 is y equals x minus 2 all squared minus 9. So part A, same deal as question 1. We need to sketch L1 and L2, label all intersections with the axes and all coordinates of intersection of the graphs, also labeling the coordinates of the turning point of L2. So this is a bit extra. We need to label the turning point of L2. Again, I'm going to keep this on just so you know that I am definitely flawed in many ways. You'll know that already if I teach you. Intersection. There you go. I'll fess up again. So let's have a look in terms of sketching this out. So some space here to just do some workings. What we need to do first, I would suggest, is think about when one equation intersects with the other. Okay, so what we need to do is think about where one of these coincides with the other. First of all though, if you have a look at this, y isn't the subject yet. So I'm going to change this top one to read y equals 2x plus 11. This one at the bottom, we can leave as it is. Okay, so now we can set them equal to each other and rearrange. So just to save a bit more space, I'm going to use this on the left to solve this. So we set x minus 2 squared minus 9 equal to 2x plus 11. Expand, simplify, rearrange, solve to find the coordinates of intersection. So if we expand this out here, what we'd get is x squared minus 4x plus 4 minus 9 equals 2x plus 11. If we now subtract 2x from both sides and subtract this 11 and simplify, what we'd get is x squared minus 6x. Just pause for a moment. 4 take 9 is minus 5. So if we subtract a further 11, minus 5 minus 11 becomes minus 16. This will now factorize. So two numbers that multiply to give minus 16, yet when we add them give us minus 6. That's going to be positive 2 and negative 8. So we're going to intersect here where x is minus 2 and when x is positive 8. We now need to think about what y would be when x is minus 2 and what y would be when x is 8. So when x is minus 2, let's just pop this into one of these equations. Let's pick the top one because this just seems easier. Okay, so 2x would become 2 times minus 2, which is minus 4. Minus 4 plus 11 is 7. Okay, so one point of intersection is where x is minus 2 and y is 7, or we could have where x is 8. Now when x is 8, 2x is going to be 16. 16 plus 11 is 27. So when x is 8, we've got that y must be 27. Now, for part A as well, what we can do, because we need to think about the turning point of L2. L2 is this. Okay, we need to remember this completed square form of a quadratic. If a quadratic is written in completed square form, this number here and the constant at the end outside of the brackets tells us essentially what the turning point is. And so what this tells us is the turning point of L2 is actually going to be 2 minus 9. That's where this parabola is going to have its minimum point. So it's going to have a minimum at 2 and minus 9. We also need to think about where this parabola will intercept the axes. Okay, so what we can do here is think about when x minus 2 squared minus 9 is equal to 0. So I'm just going to borrow some space in this part B box. So whereabouts is this equal to 0? So x minus 2 squared minus 9, set that equal to 0. Add 9 to both sides. Square root both sides. Square root of 9 is 3, but very importantly remember plus or minus. Therefore x, this is going to be intercepted where x is 2 minus 3, which is minus 1, or where x is 2 plus 3, which is 5. And so y equals x minus 2 all squared minus 9 is going to have an x-axis intercept at minus 1 and at 5. So we need to sketch this as well, having a turning point at 2 minus 9. So for turning point, let's put it down here. So wish me luck as I sketch this, because as you can see now, my sketching is absolutely pants. Do one half there, and the other half like so. Get rid of that little kink at the end as well. So I need to label this is minus 1, and that's 5. And I need to label the coordinates of a turning point of L2. So I could do with labeling this here and saying that's going to be 2 minus 9. So that's that one done. I now need to also do y equals 2x plus 11. So that's obviously going to have a y-axis intercept up at 11, and it's going to intercept the x-axis when 2x plus 11 is equal to 0. So 2x needs to be minus 11, so x must be minus 11 divided by 2, which is minus 5.5. So we can label in minus 5.5 where it intersects the x-axis. And as well as that, we may as well also add in here the y-axis intercept of L1, which is obviously 11, because we can see this when it's in this y equals mx plus c form. Now what we need to do is just realize where these graphs cross each other. So what we've seen from before is they intersect where x is minus 2 and y is 7. So we can add on this point here, as well as just labeling this coordinate. So that coordinate here is -2 and 7. And similarly, we can do the same at this one over here, which is 8 and 27. So in the same way, just labeling this in, that's 8, and the y coordinate, that is 27. So let's just label that on as well. So that's 8, 27, hence this coordinate is 8, 27. That was quite some time, wasn't it? But now we can actually look at part B. So let's just clear the space for part B now. So part B, what we need to do, if we have a read of this, is hence write down the solution to the inequality 2x plus 11 is less than x minus 2 all squared minus 9. And so 2x plus 11, okay, that's essentially L1. So what it's asking for part B is where is L1 less than, and if you have a look at this compared to L2, this is L2. So where is L1 less than L2? And if we recall what we said earlier, how we can interpret this is where is L1 below the graph of L2? L1 is the straight line, this black line here. So where's the black line below the quadratic in simple terms? Well, we can see here actually there's two different places this is true. The black line L1 is below the blue curve where x is less than -2. So from here downwards, or if I just follow this curve up a bit more, in fact, so it's a bit clearer. So if I just have this quadratic going a bit higher up as such, there we go. Or we can have where x is 8 or greater. So it's these two bits here. In between is where the black line is greater, but we're interested in where the black line is less than L2. And so we can see now that this holds true for where x is less than -2. Don't be confused with this -1. This -1 is that point there, the x-axis intercept. -2 is there. So it's either where x is -2 or where x is greater than 8. And as you can see, these two regions are mutually exclusive. They don't join together. They don't overlap. So in set form, we need to link these together with a union symbol. So in set notation, we say we were interested in x such that x is less than -2, or we could have it such that x where x is greater than 8. And that concludes the working we need for worked example 2. Let's have a look at this activity I've made for you, which is essentially just graph sketching. So for each question, I'm only going to repeat this once because it's on all the other slides. So for each question, we need to sketch both given functions on the same set of axes provided, find the coordinates of all points of intersection, and then write down the solution to the inequality f of x less than or equal to g of x. Set notation is not required in this case. So first of all, let's have a look at where we've got f of x equals 3x minus 7 and g of x equals 13 minus 2x. So because we're just sketching, we're not plotting as such, what we can do here is just think about whereabouts this would intersect the y-axis. Well, this is going to be intersecting at -7, so down here somewhere. It's going to have a positive gradient of 3. So this one's going to sort of be coming up like this somehow. Okay. whereas g of x is going to intersect the x-axis at 13, and it's going to have a negative gradient, -2. So it's not going to be quite as steep as f of x, and it's going to be coming down through 13. So maybe something a bit like that. So that's our sketch. It doesn't need to be any better than that, really. The main thing is here, find all coordinates of the points of intersection. Well, there's only going to be one point of intersection, which is here. So to find that, what we need to do is see where f of x is equal to g of x. So what we should do, first of all, is just label in which one's f of x, which is this one, and g of x is over here. We can find where they'll intercept by seeing where 3x minus 7 is equal to 13 minus 2x. So if we add 2x to both sides, on this side we get 5x, and add 7 to both sides, we see 5x equals 20. So therefore we're going to intercept where x is equal to 4, and y is equal to, well, let's have a think. When x is 4, we can just substitute this value into either the equation for f of x or g of x. So let's look at f of x. When x is 4, f of x will be 3 lots of 4, which is 12, minus 7. And 12 minus 7 is 5. So in other words, we're going to intercept where x is 4 and y is equal to 5. So that point of intersection needs to be labelled on. Which we can just do here. So 4 and 5. It says write down the solution to the inequality where f of x is less than or equal to g of x. So where is this f of x line less than or equal to the line of g of x? So where is this f of x line below g of x? Well, you can see here that f of x is going to be less than g of x down here. That's where the f of x line is less below g of x. And so the solution to this one, we can say that f of x is less than or equal to g of x for when x is less than or equal to 4. Which is what I've highlighted in yellow here. So if you want to, not that it's strictly needed, we can label this on like so. So essentially, this down here is where x is 4. So just put that on. Up here, that's where y is 5. The second one, on the right-hand side. So what we've got here is f of x is 8 minus 5x, and g of x is 14 minus 3x. And so we can sketch these fairly easily, to be honest. F of x, so it's going to have a y-axis intercept of 8. It's going to be very steeply negative. So it's going to have a gradient of -5. So this one's going to be very sort of steeply negative, something like this. Okay, whereas g of x crosses the y-axis higher at 14, but is less steep. And so g of x is going to be something that looks a bit like this. Okay, so it's going to be less steep, crossing at 14. So we just need to label on which ones we're talking about. So the steeper one is f of x. So let's label this f of x first of all. Whereas this other one is g of x. So let's find this coordinate here, where one is equal to the other. And just to get ready for labeling this, let's just put that in for the x coordinate we're going to find, and this over here for the y coordinate. So they're going to be intersecting where one is equal to the other. So we just need to solve where 8 minus 5x is equal to 14 minus 3x. So if we add 5x to both sides, we get 8 equals 14 plus 2x. Then subtract 14 from both sides, get that minus 6 is equal to 2x. So therefore we're going to intercept, if we divide both sides by 2, when x is minus 3. So we're going to intercept where x is minus 3 and where y is, well, again, let's work it out. So sub in x equals minus 3 into either f of x or g of x. Let's pick f of x. Where x is minus 3, 5x is going to be minus 15. So 8 minus 15 is 8 plus 15, which is going to be 23. And if you want to write that down, rather than doing it as I've just done sort of out loud and in my head, I would definitely recommend writing it down. I'm just saying it out loud here, not writing it down, just to keep this page relatively neat. I'm never advocating just doing things mentally and not writing down your working. So just to be clear on that point. So now we can label in this on our graph. So this point here is therefore minus 3 and 23. So the x coordinate is minus 3, for y coordinate 23. Going back to the solution where f of x is less than or equal to g of x, again it's where this f of x line is below the line of g of x. So whereabouts is that the case? Where is f of x below g of x? We can see f of x goes below g of x at minus 3 and beyond. So we're looking at this region of the line. In other words, just where x is at least minus 3. So we can write this in. So in other words, f of x is less than or equal to g of x for when x is at least minus 3. What am I talking about? Yes, sorry, that's right. Get myself confused. Yes, so when x is at least minus 3. That's correct. Okay, moving on. So, next one. We need to do the same for when f of x is x squared plus 5 and g of x is 5 minus 2x. And so let's just sketch in f of x first. So it's going to be a quadratic, y equals x squared, but just 5 higher. So it's going to be symmetrical about the y-axis, something like this. Okay. And g of x is 5 minus 2x. So let's just solve. In this case, I'm not going to sketch on g of x right now. I'm going to think about where one is equal to the other. So they're going to intercept when x squared plus 5 is equal to 5 minus 2x. Okay? We can see here we can cancel off a 5 on both sides of this equation. So x squared is equal to minus 2x. Add 2x to both sides. We get x squared plus 2x is equal to 0. This will now factorize. So we get x brackets x plus 2 is equal to 0. So therefore, we're going to intercept when x is 0. Now when x is 0, y is going to be 5. 0 squared plus 5 is 5. So that's one point of interception. Or, just get myself a bit more space, put it down here. Or we could have it where x is minus 2. That's a solution as well, where x is minus 2. And when y is going to be, well, when x is minus 2 all squared is 4, and then 4 plus 5 is 9. So these are the two different solutions. So we've got 0, 5, which is here, or minus 2 and 9. So let's say, I don't know, somewhere over here perhaps. And g of x is 5 minus 2x, so it makes sense that when we draw g of x, it's going to go through these 2 points like so. So you need to just get this a bit more spot on. Something like that. So labelling on that this is f of x, and the straight line is g of x. We now need to think about where f of x, this quadratic, is less than g of x. So where is the curve below the straight line? Well, we can see that f of x is less than g of x. The curve is below the line, in between these 2 points of intersection. We're looking at this tiny bit here. Okay? And obviously we know that this is where x is 0, because this is on the y-axis. And the other one, the other point of intersection, was where x is minus 2. So just labelling on these coordinates. That's minus 2, that's 9. This is where y is 5. So this one here, that coordinate is minus 2 and 9. And this coordinate there is 0, 5. So just going back to what I was saying earlier, where is f of x less than g of x? It's in between where x is minus 2 and 0. So the final bit for this is f of x is less than or equal to g of x for when x is between, where x is between minus 2 and 0. Like so. This one next. So f of x is 3 minus x squared, and g of x is 2x minus 12. Okay, so f of x is going to be a negative quadratic with y-axis intercept at 3. So we can sketch this on first of all. Then come back down the other side. Like so. And g of x is 2x minus 12. But again, let's just consider first of all where these might cross. These will cross where 1, 3 minus x squared, is equal to the other. So where is 3 minus x squared equal to 2x minus 12? So if we rearrange this into the standard form for a quadratic, add x squared to both sides and subtract 3, we see that x squared plus 2x minus 15 is equal to 0. This will now factorise as well. So two numbers that multiply to minus 15 and add up to positive 2, those two numbers are positive 5 and negative 3. So we get x plus 5, x minus 3 equals 0. And the solutions to this correspond to where these two lines will intercept. So obviously we could have where x is minus 5 and y is, well, let's work it out. So when x is minus 5, let's sub it into the equation for f of x. If x is minus 5, x squared is minus 5 all squared, which is 25. 3 minus 25 is minus 22. Or, so that's one equation, one solution. Or we could have where x is 3 And when x is 3, we'd have that y is equal to 3 minus 3 squared, 3 minus 9, which is minus 6. So minus 5 minus 22, that's going to be somewhere down here, say. Remember, just sketching, so it's fine. And 3 minus 2 is going to be somewhere, say, here. And 2x minus 12, we just have to draw this in now through these points. And extend the line so that it goes through and beyond both points. So let's label it all on. So that one's minus 5 and minus 22. And the other coordinates we can label on, that one over here is just going to be, oh, what's it now? I'm forgetting what it is. That's going to be 3 and minus 6. Couldn't follow my own writing there for a moment, apologies. That's 3 minus 6. So we can label on which is f of x. So f of x is the parabola, which we've got here. And g of x is the straight line, which is this one. And now what we need to do is to work out whereabouts f of x is less than g of x. Where the line f of x, this curve, is less than g of x. So where is this curve below the straight line? Well, this curve is below the straight line for this region here. And for this region here. So therefore we just need to say now that f of x is less than or equal to g of x for when x is less than or equal to minus 5, or where x is equal to or greater than 3. And that's this one completed. Now we move on to the last couple of questions of these types. So the leftmost graph, we need to think about where x squared minus 5 is going to intersect with 7x plus 13. So let's just solve this equation first of all. So set x squared minus 5 equal to 7x plus 13. And rearrange so it's a quadratic equal to 0. So subtract 7x on both sides gives us x squared minus 7x, and then subtract 13 as well from both sides, minus 18 equals 0. Now this will factorize. Two numbers that multiply to minus 18 and add to minus 7 are positive 2 and negative 9. So we can rewrite it in factorized form like this. So therefore we're going to meet when x is negative 2 and y is God knows. Well, let's just substitute it in. So when x is minus 2, y will be minus 2 all squared, which is 4, then 4 minus 5 is going to be minus 1. So that's one point of intersection. And the other point of intersection is going to be where x is 9. And when x is 9, y will be 9 squared, which is 81, minus 5, which is 76. So now we can form our sketch from this. So x squared minus 5, That's going to be a parabola which crosses the y-axis at -5, and it's going to have symmetry about the y-axis. So here goes nothing in terms of my sketch. Oh dear, that's awful. And back up again. At least that side is a bit smoother. Look at that, terrible. Anyway, so that's f of x, so I'll just label this on here. And so we're going to intersect where x is -2 and y is -1, so that might be about this point here. And when x is 9 and y is 76, so maybe this point up here somewhere like this. And do a straight line through to represent y equals 7x plus 13, in other words, representing g of x. Oops. I'll change colour, so g of x. Now let's just label on the coordinates of intersection. So we said this one over here was -2, -1, so we can label this on. And this point over here is where x is 9 and y is 76. We can now ask ourselves a question, whereabouts is f of x less than or equal to g of x? In other words, where is this parabola, this curve x squared minus 5, less than or equal to the straight line 7x plus 13? Well, we can see it's going to be in between these points of intersection. This curve is below the straight line in between these points, so we're interested in this region here. Okay, so the final thing to say is that for this one, f of x is less than or equal to g of x for when x is in between -2 and 9 inclusive. Finally, last but not least, we've got this one here where f of x is 7 minus x squared, so it's going to be an unhappy parabola, which I can just sketch in here. I say I can, but you know what my sketches are like. Up and down. Looks like the peak is there when it should be there, but again, it'll have to do for now. And g of x is 2x minus 8. But let's just see where these ones will meet each other. They'll meet when 7 minus x squared is equal to g of x, which is 2x minus 8. If we rearrange this quadratic into the standard form, we see that x squared plus 2x minus 15 is equal to 0. This will now factorise. Two numbers that multiply to minus 15 and add up to 2 are going to be positive 5 and negative 3. So therefore, this is going to have solutions. These are going to meet when either x is minus 5, because that would make this bracket equal to 0. And when x is minus 5, what's y going to be? If we sub in minus 5 into one of these equations, for example for f of x, 7 minus 5 all squared is 7 minus 25, which is minus 18. So that's one of the points of intersection. Or we could have where x is equal to 3. Oops, put that in black. We can have x is equal to 3 and y is equal to 7 minus 3 squared. Well, 7 minus 3 squared is 7 minus 9, which is minus 2. Okay, so what we're going to have here is a point of intersection, minus 5 and minus 18, so maybe somewhere down here like so. And then where x is 3 and y is minus 2, that's going to be somewhere possibly like that. And do a straight line through. And just make sure it's going through these points I've labelled, just so it actually reads as it should. That will do. And so f of x is the parabola, so I'll label this f of x. G of x is the straight line. Label the points of intersection. So the leftmost one, this one here, was -5, -18. And this one over here is where x is 3 and y is -2. Finally, whereabouts is f of x less than g of x? In other words, where is this parabola underneath the straight line, which is g of x? Well, we can see it's going to be underneath for this region here and for this region here. In other words, it's going to be below the straight line when x is -5 or less, or when x is 3 or greater. So that's what we need to just write in to conclude. So f of x is less than or equal to g of x for when x is less than or equal to -5, or when x is equal to or greater than 3. And then we're finally done. It's now over to you to have a bit more practice, and there's an important notice as well here. So in exercise 3F, just try question 3 and the challenge question if you can. As well as this, there is a very similar mini topic which is to do with regions when we're graphing inequalities. It's a small little subtopic almost which follows on from this one. So I'm not going to go into it in lesson time. So for independent study, you can read pages 53 and 54 in the book. Once you've read and digested that, then try page 55, exercise 3G, questions 1, 2, 3 and 4, and come back to me if you're struggling to understand or not sure how to tackle those questions. So once again, thanks ever so much for listening. Keep working as hard as you possibly can, and see me in class time or send me an email if you have any questions whatsoever. Thanks again for tuning in, and bye for now. Cheers.